Okay, so in one of the videos, I discussed this formula here for the lift force on an airplane's wings, and I said I wasn't going to derive it. However, I feel like it's a fairly simple one to derive anyway, so we're going to see how it's derived. So it's actually derived from the Bernoulli equation, and you can probably see how it's done already, but the assumption made is that the gauge pressure is constant. So there's constant gauge pressure, but the absolute pressure is sort of what's causing it. So what we want is to move this half rho u squared over and the p1 and p2. So you have p1 minus p2 is 1/2 rho v squared minus 1/2 rho u squared. So p1, p2 is just change in pressure, and this is 1/2 times rho times this is change in velocity squared. Now remember that pressure is force divided by area. So the change in force over the change in area is 1/2 rho times change in velocity squared. Now the area is constant, so that'll just be A. And the change in force is actually the force differential between the top and the bottom parts of the wing. So that you have one force here and another force here. The change in the force is F2 minus F1, which actually is the force of lift. Or, sorry, my apologies, F1 minus F2. It's not like it matters too much anyway. So this then becomes 1/2 rho times delta V squared times A, which you can formalize as FL is rho A over 2 times delta V squared. And that's how you derive the lift equation.